Lesson 12.2, Box and Whisker Plots. A box and whisker plot is a data display that organizes data values into 4 parts. Lower quartile is the median of the lower half of a data set. The median is the middle, so when you put it from least to greatest, it's the middle of the lower half of a data set. Upper quartile is the median, or the middle, of the upper half of a data set. And lower extreme is the least value, or the lowest number in a data set. Upper extreme is the greatest value in a data set. We use the following abbreviations for lower quartile, LQ, upper quartile, lower extreme, LE, and upper extreme. When you make a box and whisker plot, you do also want to find the median, which is the middle value in a data set. Again, we label the median as M. These 5 vocab words are the 5 numbers you need to make a box and whisker plot. In example 1, the heights in feet of the world's tallest towers are listed below. Show how the lengths are distributed by making a box and whisker plot. They do give you a nice step-by-step on how to create a box and whisker plot. Step 1. Order the data to find the median and the quartiles. We want to do this from least to greatest. So the lowest number is 1,149, then 1,198, 1,214, 1,230, 1362, 1369, 1403, 1535, 1762, and 1815. Now that we ordered from least to greatest, count inwards to find the middle, which is between these 2 numbers. Because it's between these 2 numbers, we have to take these 2 numbers, 1,362 and 1,369, and add them together. Divide by 2. This is your median, this number. Again, basically you're finding the mean of the median. The mean is when you add them and divide by how many there are. This is your M for median. Now that we split the data in half, we now find the median of the lower half. So we count in. This is the lower quartile, and we call that LQ. Do the same thing for the upper half. Count in until you hit the middle. 1,535 is your upper quartile. So we know 3 of the numbers. We actually want to find the lower extreme. Let me circle that first. This is your lower extreme. This is your upper extreme. So you see I circled the 5 numbers we are going to plot on our box and whisker plot. So we're going to plot these values. 1,149. Again, be as close as you can. Do not put the dots on the number line. That's important. You either want to put it below or above the number line. So put it, the reason is because we're going to make a box and lines and whiskers, and we don't want to overlap the number lines. Put it below. So this is your lower extreme. You probably should label it as well. 49. Okay, let's make the 5 dots again. 1214, which I'm going to say is about there. That's your lower extreme or quartile. That's 1214. The median was 1365. Again, it's just a rough estimate. 0.5. That's your median. median. 1535. About close to there. Your upper quartile, and 1815. That's your upper extreme. Now, we are going to draw a box with sides at both quartiles. So, the box goes, let me erase just to show you. You can always label it at the end. Let me just erase these numbers to show you how nice the box and whisker plot looks when you have the 5 dots. And the 5 dots should be in a line as close as you can. So here's the lower quartile, here's the upper quartile. I'm going to make a box. Try to be as even as possible. We also draw a vertical line through the median to separate the box. Then we draw whiskers from the lower extreme to the lower quartile, the upper quartile to the upper extreme. Yeah, now you can go back and probably label what these are. And even label your numbers as well, which I'll show you that's what they do here. There's your box and here's your whiskers. Example 2, we're going to interpret a box and whisker plot. Your friend's family is buying a home. The box and whisker plots show how much homes cost in thousands of dollars in 2 regions. Okay, first thing you need to know is that the box and whisker plot separated your data into 4 parts. And the 4 parts are separated by the whiskers and the boxes. This is one part. Here's one part. From here to here is one part. And from here to here is one part. What this means is this is 1/4 of your data. Each of these sections is 1/4 of your data. Or you can think of it as percentages, 25%. You may want to write this down at least somewhere on a box and whisker plot because you will need to know that the box and whisker plot is separated into these percentages or these fractions. So, what fraction of homes in region A cost as much as homes in region B? Well, region A and region B overlap right here, and that is about 1/4, 25%. So in your notes, you can notice that the right whisker for region A overlaps the left whisker for region B. That's what I just drew. So about 1/4, 25% of the homes in region A cost as much as homes in region B. Let's go to part B. About what fractions of the homes in region B cost $120,000 to $175,000. So 120 is here. We're looking at B. So 120 is there. 175 is, I'm going to say it's right there. That's the entire box. Well, that's actually 225%. And 225% is 50%. 1/2. Again, this also could say 50%. For numbers 1, 2, and 3, please pause the video and try this yourself. Remember, for number 1, you need to order the data first, then find your 5 numbers that make up the box and whisker plot. Then plot those numbers and draw the box and whisker plot. Pause the video, try 1, 2, and 3. Okay, number 1, you may need to do this on a separate piece of paper or somewhere else because number 1, we have to order it first. So 15, I cross them off as I go so I know I used them. 28, 32, 36. See, I missed a 27. I do have to erase them because I missed them. $28. 32, 34, 36, and 40. Now that we ordered the data from least to greatest, make sure you have all the data. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. We're going to go find the median, count in, halfway between 28 and 32, which is 30. So that's the median. And again, I might want to just put that down. That's the median. We are going to do 2 box and whisker plots here, the morning and the afternoon. The lower number, lower extreme, is 15. Let's find the lower quartile, which is between 23 and 27. 50 divided by 2, is 25. So that's your lower quartile. Do the same thing at the front, the upper, that's 35. Is your upper quartile. And your upper extreme is 40. So 15 is about here, 25 is about there, 30 is here, 35, and 40. Now, so the 3 middle dots have your box. Connect the ends with a whisker. Now we do the same thing with the second part of the data. So we have to put it in order. Probably the part that takes the longest is putting it in order. So we have 29. Look, we have 25. 41, 43, 45, 55, 61, and 70. Count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Find the middle, so count in. Sometimes it actually could be a number because it's even like this. You have to find mean of the middle 2 numbers, which is going to be 44. So this time we have median is 44, lower extreme is 25, lower quartile we need to find will be in between 29 and 41. Add them together, divide, it's 35. The upper quartile between 55 and 61, which is 58. And then 70 is my upper extreme. So 25, in this, now you put it right below, 25, 35, 44, slightly to the left, 58, and 70. 3 middle dots have the lines, and I make the box, and make your whiskers. So, during which part of the day do you wait in line longer? By the way, here is pretty well. Well, you could see, because of the distribution of the data, I would say the afternoon is when I waited in line the longest. About how often do you wait in line? 25 to 30 minutes during each part of the day. So 25 is here to 30 minutes is here. Well, this is, in the morning, is 25%. In the afternoon, now it's slightly less than